So I decided to make a short video explaining quadratics because I did have quite a few people who were absent several days right before spring break. So the first definition is the vertex. Now the vertex is the highest or the lowest point on the parabola. Now it could be highest or lowest based on the way that the arrows are pointing. Because if the arrows are pointing down, that means that those arrows are moving down forever and ever and ever, so there's never going to be a lowest point on that graph. But it does have a highest point right up here because the arrows are never going to move up. This is the highest it's going to go. So if it is the highest point on your graph, that is called a maximum vertex. If the arrows are pointed the other way around, so the arrows are going up this time, that means there will never be a highest point on this graph because they move up forever, but there is a lowest point, and that is called your minimum vertex. So here's how this would look if we were drawing it and looking for it on our pictures. Now on this first graph, the arrows are pointing up, so it's not going to have a highest point. But the lowest that this graph goes is right down here. And another way of thinking about that is if you had a little piece of paper and you moved up, the very first point that you hit is right there. That is the lowest point on the graph. Since it is the lowest, that would make it a minimum vertex. And then you would write the ordered pair of where it is. Now the x value it's lined up with is -2, and the y value that it's lined up with is 1. Okay, so let's look at another one. Okay. This time the arrows are pointing down, so it doesn't have a lowest point, but it does have a highest point, which makes it a maximum vertex. And when I write down where it is, the x value that it's lined up with is +2, the y value that it's lined up with is 1. And let's do one more like that. Okay, example 5. Arrows are pointing up, so I don't have a highest point, but I do have a lowest point, which makes that a minimum vertex. And this time that point happens to be on the x-axis. So just to remind you, if it's on the x-axis at -1, -1 goes in the x spot, 0 in the y spot. Now let's do another definition. Now the y-intercept. The y-intercept is the point where your parabola crosses the y-axis. And I even have the y-axis highlighted in yellow right here so that you can see exactly what I'm talking about. And when you write the y-intercept, you need to write it as an ordered pair. So let's get practice with that. Going back to example 3 right here. Okay, so here is my y-axis. The parabola crosses the y-axis right here at +5. So for my y-intercept, that would be 0, 5. Remember, since it is a y-intercept, the number goes in the y spot. Okay, so if I look at example 4, here's my y-axis. The parabola crosses that y-axis right here at -3. So that means the y-intercept is 0, -3. Okay. And one more. If I'm looking at example 5, here's my y-axis. The parabola crosses the y-axis right there at +1. So that would be the y-intercept 0, 1. Okay, so x-intercepts now. X-intercepts also have other names that all mean the same thing. They're called zeros, roots, and solutions, and that has to do with the different ways that we can find x-intercepts. Now the x-intercept is just the point where the parabola crosses the x-axis. So here's my x-axis, it's in yellow. We crossed it twice on this picture, so sometimes you're going to have 2 x-intercepts. Whenever the parabola barely touches the x-axis in one place and then shoots back up, that is also considered an x-intercept. And then right here, whenever the parabola does not cross the x-axis, you will have no x-intercepts. Okay. So more practice with that on example number 3. For my x-intercepts, if I'm looking at this picture, the parabola is above the x-axis and it's never going to have its arrows turn around. It has no x-intercepts. Okay. Now my next one, example number 4. My x-intercepts, well, here's my x-axis. The parabola, the U-shape, crosses at 1 and 3. So you would write 1, 0, and 3, 0. Okay. And one more example. On example number 5, my parabola moves down. It touches the x-axis in this one spot at -1 and then goes back up. That is considered an x-intercept. So it is at -1, 0. Okay. Now the axis of symmetry is a vertical line that cuts your parabola into two symmetrical halves, and it always goes through the vertex point because it's going straight through the middle. Now the axis of symmetry is not an ordered pair. It's an equation. It's got to have x equals something. So in this case it's x equals 1 because it crossed 1 on the x-axis. This one is x equals -3 because that line crossed -3 on the x-axis. Okay. So now, for example number 3, if I'm looking right here, here's my vertex point. If I drew a vertical line going through that point, it crossed -2 on the x-axis, which means the axis of symmetry is x equals -2. Here's another one. Here's my vertex point. If I draw a vertical line, I crossed +2 on the x-axis, so that is x equals 2. And the last one, example number 5, here's my vertex point. I'm going to go ahead and draw my vertical line going through it. That crossed -1 on the x-axis, which means x equals -1. Now there was one more thing that I did not actually talk about on this PowerPoint, is the range. So domain and range. As domain means all of the possible x values, range means all of the possible y values, and you're talking about the x and the y values that make up all the ordered pairs that are actually on that parabola. Now the nice thing about this is that domain has the same thing each time. It is all real numbers. And there is another way of writing that. If you draw an R and then you put an extra line through it, that means all real numbers. So these are going to all have all real numbers for the domain because they have arrows at the bottom, which means it's moving outward forever. And for domain, we care about the fact that it's moving out to the right and out to the left. For range, we care about the y values. Now, if this is my lowest part of my parabola, I'm going to go straight across right here. That means the lowest y value of this parabola is 1. So I'm going to take my y value and compare it to 1. From here, the arrows are pointing up, which means my y values are increasing. So I've got 1, 2, 3, 4, 5, 6. They're going up, increasing. That is greater than or equal to 1. Now, one thing I want to point out, the range does have to do with y values, but it doesn't have anything to do with the y-intercept. The y-intercept is where the parabola crosses the y-axis. So let's get more practice with range. Okay, on this one, it doesn't have a lowest point, but it does have a highest point. The highest point, the y value is 1. So I'm comparing y to 1. This time, the arrows are moving down, and if you look at the y-axis, it goes 1, 0, -1, -2. Those values are decreasing, so you want the less than or equal to sign. And this last one. If I draw my horizontal line right here, what you're actually looking for is the y value. So if this is 2, this is 1, then right here it is 0. So I'm comparing y to 0. My arrows are pointing up, which means my y values are increasing, so it is greater than or equal to.